Do you remember that you have done this experiment using convex lens? And this was what happened. First, there is a screen. You may look at the image on the screen, or you may look through the lens directly. At the beginning, the object, which is a illuminated F, is very far away. At that time, the image is formed on the screen, which is a inverted F. And next, we will move the object forward, closer to the lens. And we have to adjust the screen to form a clear image. It becomes bigger. You can see at that time the image has the same size as the object. And you can also see that you can see the image through the lens directly. Or you may look at the image on the screen. Then we move the object closer to the lens. And of course you have to move the screen further away. And the image size increases. The image distance also increases. Next, then we move the object even closer to the lens. And of course we try to move the screen further away, but still we fail to form an image. So we look at the image directly through the lens. It's quite big. We then move the object even closer and even closer. And you can see the image is always bigger than the object, but it decreases in size when it is closer to the lens. And then you are asked to repeat the experiment using concave lens. And of course there is no sharp image formed on the screen. For the rest, would you please do it yourself in the next lesson. And for the summary of the experiments, for convex lens, when the object is placed close to the lens within focal length, the image must be virtual and erect. If the object is further away, beyond the focal length, then the image must be real and inverted. On the other hand, for image formed by concave lens, it is always erect, virtual, and diminished. From these observations, we find that all real images are inverted and all virtual images are erect. And these are the answers for question 55. When you try to figure out the answer, you should notice what lens it is using in the ray diagram. For that one is convex lens, and that one is concave lens. And the other thing it is also important is to notice that convex lens converges like rays, while concave lens diverges like rays. And now what about the answers for part E and I? To explain the answer of part E, let me first of all show you this simulation. This is a ray box. There is parallel light rays, and then they converge at the focus. And now I move the ray box to one side, and you can see the light ray also converge to the point on this line, passing through the focus. You may say just under the focus. And so in this way, I draw the ray diagram for part E in this way. First, I draw a line parallel to the light ray, and then they should converge to the point, passing through the focus in this way. And so I know that the light ray may go this way. So follow the numbers 1, 2, 3 to copy the diagram. And what about part I? I have a similar simulation using concave lens. And now I move the ray box to one side. You can see when the light ray diverge apart from each other, the light rays, when they are produced backward, they converge to the point on this line passing through the focus. So, for the diagram I here, I will draw in this way. First, draw a line parallel to the light ray. Next, draw a line vertically passing through the focus. Then, the light ray hit the lens. And lastly, the light ray is refracted in this direction. The construction rules are important because they help us to find image. Let me show you some examples. This is the case for convex lens, and you can see here's the object. You may move it to the back or closer to the lens as you like. To find the image, we draw two of the construction rules. This is one, this is two. Then you can find the image on the other side. And of course, you may also draw this as well. The three light rays will intersect at the same point, and this point is the image of the tip of the object. And for the whole image, it looks inverted. What happens if the object is closer and closer to the lens? Let's see. 1, 2, and 3 if you like. See that the image becomes bigger. Let's do that one more time. Closer and closer and even closer. And now it is within one focal length from the lens. And now let me draw this and that. Oops. And you can see. Alright. In that way, then the image becomes erect and magnified. Very big. And that explains the table of section 5.4. Nature of image formed by convex lens and concave lens. Let's start with convex lens. When the object is very far away, the two light rays from the tip of the object are almost parallel, and they will converge to the single point just below the focus, in that way producing a inverted image, which is diminished. When the object is closer, you can draw ray diagrams easily, and you can see the image is still inverted and diminished. When the object is even closer and closer, then the image becomes bigger and bigger, and they are further away. You can see the image is now further away from the lens in these pictures. And what about if the object is even closer? When the object is at focus, then the two refracted light rays are parallel, and we say that the image formed at infinity. However, when the object is even closer, shorter than one focal length from the lens, then the two refracted rays diverges, so that there is an image formed behind the lens. This is a erect, virtual, and magnified image, as in magnifying glass. A convex lens gives different images depending on different object distances. But for concave lens, it will be easier. Let's take a look. The three light rays are: one passing through the center of the lens, another parallel to the principal axis, then it will be refracted this way, away from the principal axis, so that it looks like that it comes from the focus. There is already the image. Let me draw one more construction rule, which is the second one. This, the purple light ray, aims at the focus on the other side, but then it is refracted this way, parallel to the principal axis. And these three refracted light rays, they all looks like comes from this point, and we call this the image. And in fact, the image is quite small compared with the object, and we say the image is a diminished image. It is also a erect and virtual image. We will then go through some of the pictures on the next pages. So at that time, what I want you to do is label the ray diagrams here. Number 1, 2, 3, 4, 5, 6. And that's that. This is the first one. Obviously, this is a magnifying glass, or we may call it hand lens. The image is erect, and for all erect image, it must be virtual. The image is magnified, and it must be produced by a convex lens. It belongs to case 6. This is picture B. You can merely see the man inside the lens, inverted. All inverted images are real, and of course the image is diminished. It is also produced by convex lens, case 2. Picture C. The image is a diminished image, and erect, and all erect images are virtual. And only concave lens may produce erect and diminished image. Picture D. It is an erect image, and all erect images are virtual. It is also a magnified image. Magnified images are only produced by convex lens. This belongs to case 6. Picture E. This is the image. What will you say? Is it erect or inverted? If it is erect, it must be virtual. If it is inverted, it must be real. And how about the magnification? Is it a magnified image or a diminished image? Picture F. Look carefully. Is it erect or inverted image? Is it magnified or diminished? What about picture G? What do you find about the image? Lastly, picture H. You can easily see that it is inverted. Is it magnified or diminished? Check.